get English medium school. Today, in this part 2 video from the chapter of laws of motion, I would like to teach what is the Newton's first law of motion and what type of definitions he gave after given first law of motion to us, and we can explain a brief and we are discussed a brief explanation about the what definition was given after he tell or given Newton's first law of motion. Okay, so we know that what is the name of our chapter, laws of motion. So in our previous video in this chapter, we are clearly discussing that what is Aristotle hypocrisy, and the second one is what are the Galileo's observation. Okay, so the Aristotle scientist is said that every body in the on the surface of the earth initially in the rest position. Just he given one imaginary idea only, but he cannot conduct any experiments or he cannot prove that statement also. But later, after so many years, Galileo Galilei, we know that he was the famous and he was called as father of modern science, and we know that very clearly he invented a telescope. And he wrote number of books or theories about the science. That's why we are called father of modern science. But the Galileo scientist will be so practically proved if a body is in the rest, it is continues to be in the rest. If a body is already in the motion, it continue to be in the motion when no external forces are act on it. But for the second statement, he was not concerned any frictional force because of we don't have any idea about the frictional force. But later, the Newton scientist will be by considering the frictional force, so he will be explained. Means what are the observation was observed by the Galileo. The same observation was copied by the Newton scientist, but the Newton scientist will be included which one? Frictional force. But the Galileo does not include the frictional force, but Newton scientist will be included the frictional force. That's why now we discuss that. Newton's first law of motion. Newton's first law of motion. It is we are also called law of inertia. So Newton's first law of motion we are also called law of inertia. So what is the first law of motion means? If a body is in rest, continue to be in rest, or if a body is in uniform motion, continue to be in uniform motion unless compelled by any external force act on it, or simply when no forces no forces act on it, or unless compelled by any external force act on it. So means the last statement we can write as our wish. So what is the Newton's first law of motion? Or in the first law of motion, the Newton scientist will be give what type of idea to us, means if a body is in rest position, it continue to be in rest, or if a body is in motion, continue to be in uniform motion when no forces or acts on it. Means we consider all the forces present in the nature. Already these two are practically explained by which scientist? Galileo observation. But after the Newton scientist was gave this first law of motion, and he gave two important definitions or ideas after he proposed which law? First law. So Newton first law of motion were also called law of inertia. That is, keep in your mind, it is important for MCQ. So after he proposed the first law, he gave two important ideas or definition. One is the force, second one is the inertia. First one is the force and second one is the inertia. So what is the force and what is the inertia? We are discussing in this time also. Force means according to the Newton's actually in the 8th standard level, so we have some idea is there. Force is nothing but a push or pull is called force. But the Newton scientist will be explained clearly. Not only that one, means for clearly understanding, a force can change the position or dimensions of a body. Simply says that a force can change the position or dimensions of a body. That is, he says that. Means so the position of a body changes is nothing but initially the body is in the rest, it's set into the motion, means after applying the force only. Are understanding or not? So means listen very carefully. Initially a body is in the rest position. When you are applying the force on it, then what will happen? It's set into the motion. If your body is already in the motion, if you can apply some force opposite direction of the motion of your body, it comes to the rest position. That's why here, the position of your body from rest to motion or motion to rest by the applying of external force only. That's why in his first law of motion, you are observing that if your body is in the rest, it continue to be in the rest when no forces are act on it. If the external forces are act on it, what will be happen? Rest body set into the motion. And the second one, if a body is already in the uniform motion, it continue to be in the uniform motion when no forces are act on it. But if any external forces are act on it, on the body in the opposite direction of its motion, then what will be happen? It comes to the rest position. That's why. So after he gave the after he proposed the first law of motion, the Newton scientist will give two important ideas or definition: force and inertia. According to the Newton's concept, how to define the force means a force is the external cause. Simply you can say that force is the external cause which tends to change the position or dimensions of a body. Force is the external cause, means force is the main cause for the change the position of which one? Body or dimensions of a body is nothing but shape or size. So that's why. And next one is what is the inertia? What is the definition of the force according to the Newton? This is also you can write in your running notes and keep in your mind. Force is an external cause which tends to change position of a body or dimensions of a body. Next, what is the inertia? Inertia is depend on the which type of physical quantity, and what are the units of inertia and how many types are there. That is also to be discussed. It is the property of a it is the property of matter or body. Anybody I can say that it is the property of matter that resists changes in its state of rest or state of motion when unbalanced forces act on it. Listen very carefully. Inertia is the property of matter. Matter is nothing but, you know that matter is available how many forms in the nature. Okay, actually in the olden days 3 forms, but now it is the 4th form is also there, that is the plasma state. But the plasma state is the rare cases we are considered. That's why the matter is existed in 3 states: solids, liquids and gases. That's why whatever the state of the matter, that is either solid or liquid or gas. That's why everyone will have the which property? Inertia property. That's why. So here we are observing that inertia is the property of matter that resist is nothing but, okay, opposite, changes in its state of rest or state of motion when, okay, unbalanced forces act on it is nothing but, even the unbalanced forces act on it, it is continue to be in that state. That is the meaning of that. Means is nothing but simply, okay, if a body is initially in the rest position, okay, so if some unbalanced forces act on it, still it is in the rest position only. Resist is nothing but opposite. Means if a body is in the rest, if you apply the external force, it sets into the motion. But if your body is in the rest, okay, the force directly not act on it, but okay, indirectly act on it, but still it is in which position? Rest position is nothing but it is opposes the, or it is resists the unbalanced force. If already the body is in the motion, it continue to be in the motion, even some unbalanced forces act on it, that is the simply inertia. So inertia is the property of matter, means every state of the matter will be having the inertia, that is either solid or liquid or gas, but that resisted or opposite changes in its state of rest or state of motion, even unbalanced forces act on it. Inertia is depend on the mass of a body or mass of the matter. Listen very carefully. Inertia is depend on the mass of a body, because of, we know that inertia is the property of matter. Every matter, okay, so according to the science, so the matter is nothing but any object, you can say that it is okay, if you can take the any substances like okay, solid piece for example, so it is consists of number of tiny particles. Each tiny particle has some mass. That's why simply what you can say is that so inertia is the property of matter, means matter is already having which one? Mass. That's why inertia is depend on the which one? Mass of a body is nothing but simply. So if a body has more mass, inertia is also more. If a body has the lesser mass, its inertia is also less. That is the meaning of that. Okay. So what is the relation inertia and mass? That is we discussed. And one more thing is important here. So mainly 2 MCQ means multiple choice type of the questions they are asking that. Inertia is depend on dash of a body mass. This is one. And one more thing is also, what is the units of inertia and mass? Okay, so you know that the SI unit of mass is kilogram, the CGS unit of mass is grams, That's why. So inertia is nothing but what is that one? Mass simply. That's why the inertia and mass both are having the same physical side, same SI unit and CGS unit, because of inertia is nothing but it is the mass. Why? Inertia is the property of matter. That's why. Inertia and mass have same unit. Inertia and mass have same unit. SI unit is kilogram. CGS unit is gram. So that's why inertia and mass have same unit. SI unit of the inertia and mass, okay, is what is that one? Kilogram, and CGS unit of inertia and mass is gram. So here we discuss that, okay, two activities or two examples. Activity 1 for understanding the inertia and mass relation. Okay, means how the inertia is depend on the mass of a body or mass of a matter. Okay. So we are considered it is a table. So here we are observing that first of all we can take two bricks of different end mass. For example, this, okay, it is the A brick, it is the B brick. We have considered that the brick A has 2 cases, it is the 2 cases, and the brick B has 1 case. That's why what we are taken here, you can take in the 2 bricks of the different masses. Now these 2 bricks we placed on the horizontal surface of the table. Now the 2 bricks initially placed at the same position. Okay. Now we can take okay, an iron scale or any other long ruler. Okay, so the ruler we can kept at the one side of the which one means the ruler which is kept in physical contact with the 2 bricks. Okay, so means simply I says that it is a ruler. Okay, long stick or anything we are considered. It is the B brick we are considered. It is the A brick. Means here one A brick is there. Here here A brick. Here B brick is there. These 2 bricks of the other side are physically contact with the ruler or large stick is there. So now after that, okay, so at the both end of the ruler you can hold in your hand and apply the same force on the bricks in the forward direction. When means these are represented the apply, okay, application of the force on the ruler. When if a force will be applied by holding on its end, okay, you can push to forward direction. Then what will be happen? These two bricks are moved into vertically. Okay, so these two bricks are start into the motion. But at that time you are observing that. So the brick which has the larger mass will be, okay, set into the motion with a lesser velocity. But the brick which has the lower mass, that brick will be, okay, getting the more velocity. Means so one B brick will be moved fastly, but the A brick will be moved very slowly. Even though here we can hold the brick, you can hold the ruler or stick, you can apply the same force on the two bricks, but so A brick will be moved fastly, but B brick will be moved slowly. So means why? Means it has the lesser mass, it has the more mass, because of, so I say that if which body has the more mass, it has the more inertia. Means it's nothing but same force will be applied on the A brick and B brick, but okay, so what is differentiated? Mass is differentiated, but inertia is also differentiated. I says that inertia is nothing but it is resisted to change its state of rest or motion. Initially, the two bricks are in which position? Rest position. But when you are applying the force on the two bricks, then what will be happen? Okay, which brick is offers the more resistance? Resistance means opposite force. Which one? A, but B is less. That's why it has the more inertia, it has the less inertia. Inertia is more means why inertia is more? It has the more mass, it has the less mass. That's why with help of this activity we can clearly understand that which object has more mass, it is offered the more inertia. Which object has less mass, it offered the less inertia. That's why inertia and mass have the same unit, because of inertia is measured in the form of mass of a body only. Next, activity 2 we are discussing in this time. First one is loaded trolley and the second one is unloaded trolley. Okay, so we are observing that if you can consider two trolleys, one is the loaded, another one is the unloaded. Loaded trolley is nothing but it has the more mass, unloaded trolley is nothing but it has the less mass. Now we are observing that. So for example, loaded trolley is nothing but empty trolley. Empty trolley mass, just we can say that maybe 25 kg. So it is loaded trolley is nothing but the empty trolley is already filled with some substances, mass of the substances. For example, it is 100 kg, we can say that. Okay, so now both are initially we can keep onto the horizontal surface of the floor on horizontal surface of the ground. So at one place what is there? Loaded trolley is there. Instead of that one, unloaded trolley is there. Now we can try to push the unloaded trolley into the forward. It is easily set into the motion. But with the same force we can apply it on the unloaded trolley. It is very difficult or hardly to set into the motion. Listen very carefully. You are applying the same force on the unloaded and loaded trolley. Unloaded trolley can easily set into the motion, but loaded trolley it is very hard to set into the motion. But if the loaded trolley set into the motion means you are applying the more force than the force applied on the which one? Unloaded trolley. So here you are observing that both the trolleys are not. This is okay. It is a trolley. It is also a trolley. But what is the differences? Okay, the unloaded trolley will be have which mass? 25 kg. The loaded trolley will be have how much mass? 100 kg is there. That's why, so mass of a body is less means its inertia is less or nothing but, okay, when you can try to push the unloaded trolley, it easily set into the motion. But now a loaded trolley can apply the same force which is applied on the first case. So at that time you are observing that it is, okay, cannot be set into the motion. Means so the loaded trolley will be resist or opposite more on our force, but the unloaded will be resist very less. Is nothing but, so inertia is nothing but it is the property of matter that resist or change in its state of rest or motion. Here the two trolleys are initially in the rest. That's why when you apply the force on the loaded and as well as on unloaded, here the loaded trolley will be resist more force on us, but loaded trolley, but unloaded trolley will be resist less force. That's why loaded trolley will be have the more inertia and unloaded trolley will be have the lesser inertia. So at the same one, loaded trolley mass is 100, unloaded is 25. That's why, okay, so inertia is depend upon the mass of a body. If mass of a body is more, its inertia is also more. If a mass of a body is less, inertia is also less. That's why from these two activities we clearly conclude or understand that, okay, so inertia, okay, is depend on the mass of a body. That's why the units of inertia and mass are both have same, because of inertia is an imaginary property. It is the property of matter. Matter is nothing but it has the mass, first common thing. That's why, so inertia is nothing but mass. That is we are concerned. What is the SI unit of mass and inertia? Kilogram. CGS unit is gram. So that is one is there. So in the next video we discuss that what are the types of inertia. Okay. So according to the inertia concept, the Newton scientists will be, okay, give some more types of that one. Inertia of rest. It is called static inertia. Second one, inertia of motion. It is also called dynamic inertia or kinetic inertia. And the third one, inertia of direction. That's why totally three types of inertia is there. The three types of inertia we discuss in the next part of video. Okay, so what is the inertia of rest and what are the example to understand you, that is each and every part I will explain clearly with help of suitable activities or examples in the next video.